Good morning everyone. Let us try to take up an example to model a control system using what we call as phase variable method. Let us consider the system, a system described by a differential equation d3y by dt cube plus 6 d2y dt square plus 11 dy by dt plus 6y plus u equal to 0. This equation can also be written as y triple dot, that is the third derivative, 6y double dot, the number of dots indicate the order of the derivative, plus 6y dot, that is first derivative, plus 6y plus u equal to 0. We will call this equation 1. In this equation 1, u indicates the input and y indicates the output. So in order to model a system which is described by a third order differential equation, you would require 3 state variables. I recall that the state variables are represented by x's. That is, the state variables for this particular system can be represented by x1, x2, x3. Let us try to model the system. Let the first state variable is output itself. That is x1 equal to y. The second state variable x2 is the first derivative of the first state variable. That is x2 is x1 dot, which is equal to y dot. Now the third state variable x3 is the first derivative of the previous state variable, that is x2 dot. This can also be written as x1 double dot. This is also equal to y double dot. Now y triple dot can be seen as x3 dot. Substituting the values of y dot, y double dot in equation 1, we will get the following equation. That is, equation 1 becomes y triple dot plus 6 for y double dot, we will put x3 and plus 11 for y dot, we will put x2 plus 6 for y, we will put x1, u we will retain equal to 0. Now y triple dot can also be written as x3 dot. We will substitute x3 dot to y triple dot and send all the terms onto the right hand side. So x3 dot equal to minus 6x1 minus 11x2 minus 6x3 plus u. Now we look at these equations. That is, x1 dot equal to x2. This is our equation 2. We will call this equation as equation 3. That is, x2 dot equal to x3, and this is our equation 4. Now what we do is, we will try to rewrite equation 2, 3, 5 in the manner which is required for modeling. That is, equation 2 is written as x1 dot equal to x2. We will only retain that much. x1 dot equal to x2. This is equation 2. And x2 dot equal to x3. That's our equation 3. We will skip the remaining terms. We will not write them. So equation 3 is x2 dot equal to x3. This is equation 3. And equation 4 is x3 dot equal to minus 6x1 minus 11x2 minus 11x3 minus u. This is equation 4. See, now if you look at equation 2, 3 and 4, they are in the required form. That is, the derivative of the state variables are the linear combinations of state variables and input variable. That is what is needed for us. If you look at this, x1 dot equal to x2. So x1 dot is the derivative of the first state variable, which is equal to x2. This is a state variable. x2 dot is the derivative of the second state variable. This is equal to the state variable x3. x3 dot is the first derivative of the state variable x3. This is equal to minus 6x1 minus 11x2 minus 6x3 minus u, which is the linear combination of the state variables and the input variable. Now we will put equation 2, putting equations 2, 3 and 4 in vector matrix form. We get x1 dot, x2 dot, x3 dot equal to x1 dot equal to x2. That means there is no x1 term, it is 0. There is x2, 1 into x2, there is no x3. So we have put the first equation, x1 dot equal to x2 in this manner. The third equation, equation number 3, that is x2 dot equal to x3, is written as there is no x1 term, there is no x2 term in x3 in the equation 3, and there is 1. And x3 dot equal to minus 6x1 minus 11x2 minus 6x3. So it's written this way: x1, x2, x3 plus, there is no input term in this equation number 2. That means it is 0. There is no input in equation 3. That again is 0. And in the fourth equation, this is minus 1. Indeed. This resembles x dot equal to a into x plus b into u. Where A is given by this matrix, B is given by this matrix, and this is your state equation. Now, we also have the output y equal to x1. This is how we have described our first state variable. So this is the equation, this is the output equation, which is in the required form. That is, y equal to, there is x1, so coefficient is 1. There is no x2 term, 0. There is no x3 term, 1, 0, 0. x1, x2, x3. This is what we call as output equation. This is matrix C. That is, in the standard form, we write it as matrix C into X. So this is the output equation. Alright, state equation and output equation. So these two equations completely describe the given control system in state variable form. Hope you have understood this. Thank you.